let's talk about arithmetic sums. So there's a great story that goes with arithmetic sums. And this fine-looking gentleman here, his name is Carl Friedrich Gauss. And I'll let you read the quote on your own time. It's a great quote from his about learning. But he has a famous story. There's a famous story associated with him in arithmetic sums. And the story goes like this. Not sure, a little bit of confusion whether he was in trouble when he was in school or not as a youngster. But nonetheless, the teacher in his class gave them the assignment to take all of the numbers, all of the integers, from 1 to 100 and add them up. And then tell her or him when they were finished adding those up. And the teacher thought that they would buy some peace and quiet for a little bit while the kids worked on that assignment. And Gauss finished in seconds. And the teacher was shocked and added up all the numbers from 1 to 100, and he was correct. So here's the shortcut that Gauss used. He wrote down a list something like this: 1 plus 2 plus 3 plus 4 plus 5 all the way up to 100. And then underneath it, he wrote the same sum, but he went the other direction. He went 100 plus 99 plus 98 plus 97 all the way down to 1. And then he added vertically. So he lined those two lists up and added vertically. And look what he got. 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. 4 plus 97 is 101. And so on, even all the way down to 100 plus 1 is 101. Great. Well, repeated addition is just multiplication. How many 101s are there? Well, the black numbers have counted them for us. There are 100 of these. So the sum of the first 100 digits is 100 times 101, because you have 100 101s. But there's a problem. We just added those numbers twice because we added 1 to 100 and then we added 100 down to 1. So we have to divide our answer by 2. And when you do that calculation, 100 times 101 divided by 2, you've got 5,050. Super cool. So Gauss, as a youngster, stumbled upon the formula that we're going to use for adding up arithmetic sums. So here's what I want you to notice when we're breaking apart this formula, because first thing I want you to notice actually is that he has an arithmetic sum here. The numbers 1, 2, 3, 4, 5, up to 100 make what we call an arithmetic sequence, meaning they have a common difference. Common difference here is kind of nice. The common difference is 1. So they have there's an arithmetic sequence here where the common difference is 1. And if you watch the previous video that I did, a sequence is just a list of numbers. So when you put commas between them and you have a list, this makes up a very simplistic arithmetic sequence where your common difference is 1. What Gauss did is he took the entries in this arithmetic sequence and he added them together. We call that a sum when you add those things together. So here's how I want to rewrite the sum that he used so that we can use it for our formula. 100 over 2. So I'm going to take this 100 over 2. And then the 101, I'm going to rewrite that as 1 plus 100. Fair enough. 100 is 1 plus 100. Well, of course, because the 1 plus 100 is the sum that we were adding up, all those 101s. Here's how we can generalize that even further. 100 was how many terms we have. One is your first term. 100 is your last term. So if we add the first term to the last term every time, add those all up, first term plus last term, we will have n of them, however many terms there were. But we just double counted, so divide by 2. So this formula right here is the formula that we're going to be using for even more complicated arithmetic sums. Okay, let's extend this formula and find the sum of the following terms of this arithmetic sequence. So 3 plus 8 plus 13 plus 18 plus 23 plus 28. And the first thing I want you to notice is that these terms, 3 and 8, 8 and 13, 13 and 18, make an arithmetic sequence. So 8 minus 3 is 5, just like 23 minus 18 is 5. So our common difference is 5. So this is, in fact, arithmetic. And we can use that formula up there that Gauss stumbled upon in order to find the sum of these terms. So what's great about this is we just need 3 pieces. We need to find n, well, so how many terms we're We need to find the first term, and we need to find the last term. Now generally, when you have a sum like this, 2 of those are easy to find, and 1 of them is more challenging to find. So in this case, I can pretty easily see that our first term is 3, and our last term is 88. So if I'm going to use the formula S for sum, n over 2, first term plus last term. The first term and the last term are great. It's just that n. I don't know how many terms I have. 3, 8, 13, 18, 23, all the way up to 88. So here's how I'm going to find that. I'm going to use the formula that we worked on in the last section. A sub n equals a sub 1 plus n minus 1 times d to find a formula for the a sub n's. It will have n in that formula, and then I can solve for n. So now I'm going to do a problem just like I did in the previous video, where I'm finding the formula for that arithmetic sequence. Okay, first term is great. First term is 3. Oh, and we figured out previously what d was. D is 5. So actually, all of the heavy lifting for this is pretty much finished. N minus 1 times 5 from our previous work is done. Great, there's our formula for a sub n. A sub n is 3 plus 5n minus 5, or in other words, a sub n is 5n minus 2. Okay, now in our formula over here for the sum of those terms, I don't need an a sub n, I need what n is. So here's what we're going to do. We need to find n for the 88th term. So let's take 88, plug it in for a sub n, and figure out what n is. That will tell us how many terms. So adding 2 to both sides gives us 90. Dividing by 5 gives 18. So apparently this is the 18th term. if we go all the way out to 88. Great. So now we can take each of those pieces and plug this in to find the sum. There were 18 terms if we went from 3 to 88. The first term is 3, and the last term is 88. Cool. 18 divided by 2 is pretty nice. That's 9. And 3 plus 88 would be 91. 9 times 91 is 819. Great. So here's what we did, just a quick recap. We used our formula here for our sum, or up here. We needed to know n, how many terms goes. First, if you start at 3 and go up to 88, how many terms was that? In order to find that n, that was the hard part. We needed to find the formula just like we did in the last section, in the last video. But we needed n, we needed the first term, and we needed the last term. Let's do another example just like this. Okay, let's find this sum. Let's find the sum of the terms of the arithmetic sequence 130 plus 126 plus 122 plus 118 plus 114 all the way down to 54. Okay, so we're going to use our formula again, n over 2 times the first term plus the last term. And really similar to the last problem we just did, the first term we can see really quickly. The last term we can see really quickly. Ooh, let's double check and make sure it is in fact an arithmetic sequence. So let's see, excuse me, 126 minus 130 is negative 4. And let's do this one, 114 minus 118. Yep, sure enough, that's negative 4. So our D is negative 4. Okay, so it is in fact arithmetic. Now I don't need D in my formula for my sum. I need D to help me figure out what n is in my formula for my sum. So right down here, we're going to use the summation formula, n over 2 times the first term plus the last term. And if we need to find n, we need to find the formula for a sub n, just like we did in the previous video. And remember, the formula for the a sub n's in the previous video was the first term plus n minus 1 times the difference. Oh, great, we have all that information. The first term is 130. And the common difference we figured out was negative 4. Cool, so we have a great formula for a sub n. A sub n is 130 minus 4n plus 4 gives 134 minus 4n. Okay, now remember what our goal is. We're finding this formula so we can plug in that last term of 54 and figure out how big n had to be in order to get there. So we're just using this to find n. So we're going to find n for the last term. So we're going to plug in 54 equals, I would like to erase, whoops, try that again, there we go. I'm regretting that circle right there. Okay, better. So 54 equals 134 minus 4n. Okay, a little bit of algebra here. Subtracting 134 from both sides, actually, we have 54 minus 134. And that is negative 80. And dividing both sides by negative 4 means that n equals 20. Great. So now we can use that to plug it into our formula. S equals 20 over 2, first term plus last term. 20 over 2 is 10, and the first term plus the last term is 184. So apparently this is 1,840 for our sum. Cool. Okay, let me show you one more type of writing the question for finding arithmetic sums. A letter that we commonly use in mathematics when we're looking for the sum is the Greek letter for S, which is a sigma. Whoops. And here's how we write this. Let's say I wanted you to add up the sums of the terms of the arithmetic sequence 2n minus 5. So if I were to erase this momentarily, 2n minus 5 is my a sub n. And if I want to tell you to add those, I would write sigma in front of that for sum. Sometimes you'll see parentheses around what you're supposed to add, but not always. And then I need to tell you where to start and where to end. So I'm going to tell us, let's start at n equals 1, and let's add up the first, 12 terms. So down here we put where we start, and down here we put where we end. Okay, so let me show you what this looks like really quickly before we do this whole example. This means when n equals 1, if I take n equals 1 and plug it into my formula, 2n minus 5, I've got 2 times 1 minus 5, which I know works out to, let's see, 2 minus 5 is negative 3. I'll use a different color. When n equals 2, if I go to the next term in the sequence, that would be 2 times 2 minus 5, which is 4 minus 5, so negative 1. Then if I did the third term, when n equals 3, that would be, let's see, 2 times 3 minus 5 is 6 minus 5, that would be 1. And so on until I got to n equals 12, but I don't really have room to write here. N equals 12 would be, I'll write it up here, 2 times 12 minus 5 is 24 minus 5, which is 19. So if you look at this rainbow colored sequence that I have right here, negative 3 plus negative 1 plus positive 1 and so on, here's what I want you to notice. It is an arithmetic sequence. The common difference, negative 1 minus negative 3, negative 1 plus 3, is 2. Oh yeah, we're adding 2 each time. 1 minus negative 2, 1 minus negative 1 is 2. So our common difference is 2. Oh shoot, should have known that. Common difference is 2, and 2 is the coefficient of n in our formula. So that is our common difference over there. But we can figure it out once we see the terms. So what this means is sum means to add. So sigma means add. Add all the terms with the formula 2n minus 5. Start at n equals 1. Stop at n equals 12. So here's n equals 1. We plug it in. We figure out what that number is in red. Then go to n equals 2. Plug that in. Figure that out. That's what we get in green. Then go to n equals 3. Then go to n equals 4, and so on. And stop when you get to n equals 12 and add up all of those terms. Okay. That's the main idea of what's going on, but I want to not add up all 12 of those terms, so here's what we're going to do instead. Instead, we're going to use our formula. Remember, we had that formula for arithmetic sequences, n over 2 times the first term plus the last term added together. Okay. Oh, you know what we know this time? We know n. We know how many terms we're adding up. We're starting at 1 and ending at 12. So in this one, n must be 12 terms. Okay. Now we need to figure out the first term and the last term. Okay, I know, I already figured out the first term. But how did I figure out the first term? Is I took n equals 1 and I plugged it in. So the first term, let's see, this is going to be n is 12 over 2. First term is negative 3. Oh man, I even figured out the last term, didn't I? Last term is 19. Now how did I figure out that 19? I took 12, plugged it into the formula, and found out the last term. Cool. So n, this will tell you the ending point for n. That's what we plug in here. That's how many terms we have. Plug in n equals 1 to find your first term. Plug in whatever the ending term is, n equals 12 in this case, to find your last term, negative 3 and 19, and you have your formula. So let's see, 12 over 2 is 6. Negative 3 plus 19 is 16. And 6 times 16 is 96 for our sum. Okay, let's do one last example. Okay, let's find the sum of the sequence given by negative 2n plus 1, starting at n equals 1 and stopping at n equals 30. So we're going to find the sum, I misspoke, we're going to find the sum of the terms of this sequence, starting at n equals 1 and stopping at n equals 30. So I just want to show a couple of things. Excuse me. Since this is arithmetic, our formula we're going to use for this sum is the same one we've been using, n over 2 times the first term plus the last term. Well, we have part of that already. Fill in all the pieces. We definitely know how many we're adding up. We're going from 1 to 30, so n is 30 terms. What we need to know is the first term and the last term. Okay, so plugging in these values, the first term would be plug in, n equals 1. So that would be negative 2 times 1 plus 1, which is negative 2 plus 1 is negative 1. And just for fun, you can plug in n equals 2 and so on, but the one you really need is n equals 30. So don't know what all the terms are in the middle, but you can find them if you want them. You really just need the very, very first term for when n equals 1 and the very last term for when n equals 30. So when n equals 30, we've got negative, let me write it up here, negative 2 times 30 plus 1, and negative 2 times 30 is negative 60, plus 1 is negative 59. Cool. Okay, so our first term is negative 1. Our last term is negative 59. Let's see, 30 over 2 is 15. And negative 1 and negative 59 makes negative 60. And 15 times negative 60 is negative 900.